This amazing new solar system discovery, the Sun used to have Saturn-like rings that stopped the Earth from being a super-Earth. And we have images here of false color images revealing series of rings around a young star, HD 163296. This is what our earliest sun, looked like from what the scientists are saying. This is by Yasemin Saplakoglu, Live Science on Science Alert. Before Earth and the other planets in our solar system existed, the Sun may have been surrounded by giant rings of dust similar to Saturn's, according to the new study. Those rings of dust may have prevented Earth from growing into a super-Earth, a type of planet that's about twice the size of Earth and up to 10 times its mass, according to NASA. Astronomers have discovered super-Earths orbiting about 30% of Sun-like stars in our galaxy. The occurrence of super-Earths in so many other solar systems left astronomers with some unanswered questions, namely, if super-Earths are super common, why don't we have one in the solar system? Andrea Isella astrophysicist, Rice University, Houston, Texas, said. And to find out, Isidoro and his colleagues created a computer simulation model of the formation of the solar system, which emerged from the ashes of a collapsed cloud of dust and gas known as a solar nebula. Live Science previously reported. Kindly support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box. Their simulation suggested that pressure bumps or high pressure regions of gas and dust would have surrounded the infant Sun. These areas of high pressure likely resulted when particles moved towards the Sun under its strong gravitational pull, heating up and releasing large amounts of vaporized gas. The simulation showed that there were likely 3 distinct areas where solid particles vaporized into gas, called sublimation lines. In the line closest to the Sun, or the hottest zone, solid silicate turned into gas. In the middle line, ice would have heated up enough to turn into gas, and in the farthest line, carbon monoxide became a gas. Solid particles like dust sort of rammed into these bumps and began to accumulate, the simulation showed. The effect of the pressure bump is that it collects dust particles, and that's why we see rings. This is what co-author Andrea Isella said, associate professor of physics and astronomy at Rice University. So if these pressure bumps did not exist, the Sun would have quickly gobbled up the particles, not leaving any seeds for the planets to grow. One needs something to stop them in order to give them time to grow into planets, Isella said. And we have the image here, the asteroid belt formed by implantation of the outer solar system materials. The inner solar system materials, mostly from Mars region. Mars being the 4th planet from the Sun. We have Mercury, Venus, Earth, and Mars, and then the asteroid belt. Then the H2O snow line, and the cc planetesimals, mostly feeding the outer solar system. And then we have the bigger planets and the Kuiper belt objects. Now, with age, the gas and dust surrounding the Sun cooled down and the sublimation lines inched closer to the Sun. This process allowed the dust to accumulate into planetesimals, or asteroid-sized seeds of planets, which could then come together to form the planets. Isidoro said, our model shows pressure bumps can concentrate dust, and moving pressure bumps can act as planetesimal factories. The pressure bumps regulated how much material was available to form planets in the inner solar system, Isidoro said. And according to the simulations, the nearest ring to the Sun formed the planets of the inner solar system, Mercury, Venus, Earth, and Mars. The middle ring would ultimately become the planets of the outer solar system, while the outermost ring formed the comets, asteroids, and other small bodies in the Kuiper belt, the region beyond the orbit of Neptune. What's more, the researchers found that if they simulated the delayed formation of the middle ring, super-Earths may have formed in the solar system. Isidoro said, by the time the pressure bump formed in those cases, a lot of mass had already invaded the inner solar system and was available to make super-Earths. So the time when this middle pressure bump formed might be a key aspect of the solar system. The findings were published December 30th in the journal Nature Astronomy. This was originally on Live Science, and it's on Science Alert. Please leave your comments, and thank you for your support.